On section 4.4 of the grade 9 academic course called Modeling with Formulas. And really what I want you to be able to do before you move on is to solve problems that have variables in them, the variables that have meaning in this case. And I call it subbing and solving. And what that means, what I'm asking you to do then is to not just sub in numbers and solve, but to also rearrange equations if you need to, or formulas or equations, kind of using those two words. I call that isolating a variable. You're getting what you're looking for by itself. So in this case, if I said this was an equation, distance equals speed times time, which is an equation you know instinctively. You know that if you drive at 100 kilometers per hour for 2 hours, your distance is 200 kilometers, right? You just multiply that. If I wanted to isolate speed, I would have to rearrange this equation. And so we call it rearranging equation, isolating a variable, a few different words, a bit of language that we used to meet that objective. Pretty much, though, what you need to do then is use opposite operations, rearrange an equation, to get the variable you're looking for alone and generally on the left-hand side of the equation. So let me get right into showing you what I mean. So these are all what I call application type questions because they have very specific, in this case, we're taking the most famous equation ever, which is Einstein's equation, E equals mc squared, to solve for mass. So in this equation, by the way, E is for energy, m is for mass, and c is actually the speed of light squared, or c squared is speed of light squared. So speed of light is a constant, 3.0 times 10 to the 8 meters per second, all of which you don't need to know. That's not part of the grade 9 course. It is part of the grade 12 physics course, though. And what you need to know out of this is just how to, what we call, rearrange that equation or isolate m. Okay, so you want to get m by itself. So the first step is that I take is to write the m, just flip it around. So the one I'm looking for, which is m, is on the left-hand side of the equation. That's not a required step, but it's good communication, easier to follow. The next step, because m is multiplied by c squared, is to divide both sides by c squared. And I cross them out here because top and bottom both have c squared, so those cancel. And you end up with the answer, which this is m isolated, right? M is E equals c squared. So if you needed to sub and solve for mass, I could give you c, I could give you E, and you could rearrange that and find out mass, just so you know what it means, by the way. This particular equation means, if you have, in this form, it means, if you convert amount of mass to energy, how much energy can you get? And the reality is it's huge. The example I give the kids in physics is if you had about 1 gram, which is about the amount of uranium that would fit on your pinky finger, and it turned it all to energy, which is what the nuclear bombs in Japan did, you would think that's the amount of actual mass that converted to energy and destroyed a whole city. 70,000 people killed in one shot with 1 gram of uranium turning into energy. Anyway, that again is a physics lesson, not a math lesson. Back to math. One other physics equation, though. This is the equation for speed, distance, and time. And it's a weird thing in physics and in lots of things. Sometimes the letter that gets appointed to a certain variable doesn't make sense. And V for speed doesn't make sense until you've taken physics. It kind of means, if you've heard the term velocity, I think it's Despicable Me, velocity guy or something like that, vector, no, it's vector. But velocity is another, let's just say for now, it's another way of saying speed, and that's why we use V. So V is speed, D is distance, T is time in this equation. And the question is, if he drives for 3 hours at 100 kilometers per hour, how far does he drive? Well, I like to use graphs for these questions, so list my givens. Speed is 100, T is 3. I'm looking for D. How far means D. First step in rearranging is I took the equation and I flipped it around again to get D on the left. And then I have this fraction. I killed the fraction by multiplying both sides by T. So see, I put this T here, times T. I'll erase that actually so you can see better. So I multiply both sides by T. Here's the T and there's the T. And because that's on the top, that's on the bottom, they cancel. And you end up with distance equals speed times time. Finishing then, I substitute in, and that's what this S stands for, is substituting in. So speed times time, and so he drives 300 kilometers. The next example, again, if you need to pause, please do, is this is a perimeter equation. Perimeter for a rectangle is 2 times length plus 2 times width. And just so you get a vision of what I mean, you know, you have a rectangle sitting there, and the perimeter is the sum of all the sides. Well, on every rectangle, there's 2 lengths and 2 widths. That's what that means. Okay? So a rectangle with a perimeter of 14 centimeters and length of 5, what's the width? So just going through graphs again, perimeter is 14, length is 5, looking for the width. There's the formula, but I need to rearrange it for W, right? Width, so I have to isolate width, or W, in this equation. Okay? Maybe before I go any further, you could write down my notes, which is that when you look at this equation here, you could right off the top put in 14 here and put in L as 5 and then rearrange to get W by itself. And that's what I say is, you know, being creative in your strategy. You're following a different strategy than I'm going to show you, but it's still correct. And you'll still get the same answer. So if you chose to do that, like sub the numbers in right away and then rearrange, that's fine. I'm going to show you how to rearrange first, though. But it doesn't have to be that way. Same step again. I put the W, the side with the W on the left, so I just rewrote the equation. Now, I have to get W by itself, so subtract, first I have to get rid of this term. So subtract 2L from both sides. So 2L minus 2L is 0, so just then I end up with 2W equals P minus 2L. Now I get W by itself, so divide both sides by 2 to get W by itself. And that ends up being my equation. W equals P minus 2L over 2. Okay? Now once you have that, you have to remember that it's not that hard to deal with because these are just, like, we know P is 14 and minus 2 times L and then just over 2. So that's just taking this equation, right, and substituting in the numbers I have. And, you know, you rearrange 14 minus, that'd be 14 minus 10, which is 4 over 2, so W equals 2. So therefore the width is 2. That's it for this page. Moving on, another example. So here's where you have a square root, and here you have to know that the opposite operation to something squared is the square root. Okay, so in this question we're given the area is 35 centimeters squared, and we need to find the radius. Okay, so given A equals 35, pi, you know, is 3.14. You should use your pi button, by the way, to be more accurate. R is what we're looking for. So as you can see, when I applied my formula, the first thing I did was put R on the left. I just rewrote this equation with R on the left. To get R squared by itself, I divided both sides by pi. Then the pi cancels, so I have R squared equals A over pi. Then to get R, here's the opposite operation. The last opposite operation is take the square root. So then R must be the square root of this. Okay? So when you're dealing with something with a square that's squared and you have to isolate it, get it by itself, you have to take the square root of the other side. And then you can substitute in numbers. Here's a little thing. If that dot looks, familiar to you, I'm sure you're not tired at all. You're wide awake and perky listening to math lessons. That little dot right here represents approximately equal to, because as soon as I entered pi into the calculator, I started rounding. Right, so these are rounded answers. Anyways, but you know, so I say the radius is approximately 3.3. It's not exactly 3.3. It's exactly square root of 35 over pi. That's an exact statement. This is not. Okay, another example. Okay, oh, kinetic energy. This is another physics thing. So here is an equation for energy, and again, you don't need to worry too much about what's what, except for, you know, to be able to know enough to substitute in numbers and such. So it says a 1,000-kilogram elephant has a kinetic energy of 500. How fast is he moving? So in this equation, the E is the energy, the M is the mass, and the V is the how fast, the speed. Okay, and that's what the question is looking for. So here I start subbing in. Given E equals 500, M is 1,000, M for mass, right? Looking for V. So here's my equation as it was given. again, the first thing I did was write it with the v, which I want to find, on the left. Okay, this step here is me killing the fraction. I want to get rid of this 2. What's 1/2, right? So I multiply 2 by both sides, and again, when I do that, this 2 cancels with this 2. Okay, and then you just end up with 1 mv squared, which is just mv squared. Excuse me. So mv squared equals 2e. And again, I'm not done yet because I have to find v, right? So divide both sides by m, and again, the m cancels. Now I've got v squared equals 2e over m, and once again, just like the last one then, I need to find v. You take the square root. Okay? So that's a big one, lots of rearranging there. And what do you do at the end then? You substitute in the numbers. So we're given an equation 2 times e, so there's the 2. The e is 500, and then the mass is 1,000. This one works out quite nicely because 2 times 500 is 1,000, so 1,000 over 1,000 is 1. So the speed is the square root of 1, which is just 1. So I don't even have to say approximately equal to. It's perfect. Okay, so anyways, make note of any questions you have, and that's it for today.